let's see like what are the different variations when we perform convolution. The previous case, we were trying to place this kernel at as many locations as we can. Now there is a concept called stride, and this is like one of the hyperparameters of your convolutional neural networks. Stride defines how many pixels you are going to skip when you move from one location to the other location. All right, so let's start from this location. If we have like stride of 1, then we will start from this location, we'll go to this one, so we won't skip anything. Okay, if we have a stride of 2, then we are going to skip one value. So this is the first location, then the second location is going to be this one, and then the third, again we skip one, we go to this. All right, so you can see that activation map of 7x7 filter 3x3, if we use a stride of 2, we were only able to place at 3 different locations, which means the size of the activation map is only going to be 3x3. Similarly, I think in the y-axis as well, you will only be able to place it like 3 different locations. So that's fine. So that's the concept. Now the question is like, why exactly we need stride? And there are a lot of reasons. I will give you a couple of them. One reason is if you think that your memory consumption of activation map is too high, and you don't want to actually process all the locations, you want to reduce that. Okay, so it in a way is like a memory optimization. Earlier, if you placed at every location, you are going from 7x7 to 5x5. In this case, you're going to 3x3. So it's kind of you're reducing the volume, or you can say like the shape of your activation map. You can try to optimize in terms of memory. So that's one motivation. The other motivation is, let's say you are using a very high resolution image. And in that case, if in a neighborhood, nothing is changing, and it's not like a drastic change as you move from this location to this location, then what will happen is the output activation will be very close when we place the kernel at this location and at this location. To try to reduce that redundancy, you can actually use a stride so that you don't place at every location and you try to skip. Okay, so that's like another motivation. And there are other reasons as well, but you don't have to worry about that right now. Okay, so again, the formula we had, we can update that to incorporate stride into to take stride into account. And the formula now becomes N is like your size of input activation map, F is the filter size, and S is the size of the stride. Okay, so this is your updated formula. And you can like put these values here, 7, 3, and 2, and that's going to give you your shape of your output activation map. Okay, so it's that. Now another interesting thing is, since stride is a hyperparameter which you will have to set manually, like when you design your convolutional neural network, so you'll have to be a little careful about that, because it may happen that like some strides are not compatible with your filter, or you can say like your activation maps. And so let's try to understand when that may happen. So if you have an input of 7x7 and you have a filter of 3x3, and you wanted to apply like a filter with a stride of 3, you want to optimize like a lot. So then this will be the starting location. Then you will skip, and then you will reach this location. Okay. Then you will see you can't put it here. And again, you are at the end, you're at the edge, right? Which means that when you are actually trying to transform this activation map into another activation map, when you're trying to extract features, you completely ignored this column and potentially the last row as well. So that's kind of like loss of information, right? And that's not, you don't want that. So which means that not all strides are actually compatible. And one simple thing you can do is you can try to find out for a given input activation map and the filter size, like whether your stride will fit or not. Okay. So a simple way is like you put that in your equation, and if it gives you like a perfect number, then that's possible. For example, if you use a stride of 1, it gives you 5. Stride of 2 gives you 3. Stride of 3 is giving you fractions. which means that these are not compatible. So a very simple trick to figure out whether your activation map size, your filter size, and stride are compatible or not. Okay.